DengAI, predicting disease spread.
Greetings everyone. I, Prachi Pamar, on behalf of team number 78, would like you to introduce to our topic DengAI, predicting disease spread. Dengue fever is a mosquito-prone disease which generally occurs in tropical and subtropical parts of the world. Its symptoms ranges from mild ones like flu, fever to severe ones like bleeding, low blood pressure, and in some cases can even lead to death. As dengue is mosquito-transmitted disease, it is generally influenced by factors like vegetation, precipitation, temperature, and many more. Thus, our aim is to train a model such that which will be able to predict the number of dengue cases in a locality or an area, thus easing the work of our medical heroes and also enhancing the treatment skills. Following in this video are my fellow teammates who would brief about the topic some more.
Hi, I am here to discuss about ARIMA and ARIMAX model. ARIMA, Autoregressive Integrated Moving Average model. It belongs to the most used methodology for analyzing time series, and it has a great flexibility in analyzing time series. So it has an accurate forecast in analyzing. When an ARIMA includes input variables at its time series, it changes to or referred to as ARIMAX. ARIMAX includes exogenous data. We can say it as some essential features like that, some variables. For example, just temperature, etc., etc. So ARIMA and ARIMAX are most used time analyzing models. We can look upon its code and other things. So this is a coding for ARIMA model. When we look upon this one is ARIMA models features given. This is train features. Total cases is given. Stationary even is true and trace is true. Then the hyperparameters are there when we look at this. These are the AAC values, and as we know, if the AAC value is higher, the model will be not very good, and vice versa. These are the totally AAC value. Then we look around. This is ARIMAX model. ARIMAX model contains the features. These are the features included in this ARIMAX model. And in ARIMA model, if you look upon, there is only a predecessor, but in ARIMAX model, we can give the features.
So now I will be discussing on Sarima and Sarimax models. Okay. So the main difference between Sarimax and Sarima models and ARIMA model is that ARIMA models cannot handle seasonal components, whereas Sarima models can handle seasonal components. So this is the main difference between it. Okay. And in our data set, in our problem, we are having seasonal variance. So Sarima model will be more suitable when compared to ARIMA models. Okay. Now we can go to the code of Sarima models. Here I have created this Sarima model object, and I have done it with train target, that is our total cases, and given seasonal equal to true, that is seasonal data is taken into consideration. Trace equal to true, seasonal true. So what is the main advantage of auto ARIMA is that in Sarima models we are having different hyperparameters P, D, Q, and all. These are the trend and seasonal components. Both are present in ARIMA models. That is, there are trend autoregressive orders, season autoregressive orders, differencing autoregressive orders. So all those stuffs are present in ARIMA models, and these will be automatically generated with the help of auto ARIMA. Okay, that's all about it. And I have just fit the model and made a summary. So we get to know about the AIC values, and we should take into consideration those values again. So lower the AIC value, better the our model is, and the accuracy of our result will be more. This I have done with SJ data, that's San Juan data. Similarly, I have done with Iquitos data, and I got the AIC values, and it was better when compared to ARIMA models. So I have finalized with those models, and made a submission in the driven data competition, and I got a rank of 2186 out of 9076 competitors. So that's all about it.
Let's move on to machine learning. The algorithm that we used is random forest. This is an ensemble approach, which means that the output of the other algorithms or weak learners is combined into a weighted sum that represents the final output of the boosted algorithm. In case of random forest, the dataset rows are divided into samples and the features are divided into feature sets. Random combination of these samples and feature sets are given to multiple decision trees, each of which gives some output. Since our problem statement is of regression, the random forest regressor is used, which takes the mean of output of all decision trees as the final output. The hyperparameter considered is number of estimators, which is the number of decision trees used. Let's look at the code now. Here we've made a list of the number of estimators to be passed on to the model. Find best param function tries out different parameters, calculates the loss, and returns the model with the best parameters, which are then passed on over here. These parameters are passed as arguments to the number of estimators in the random forest regressor model. After fitting the model, we compare the predicted and actual values in the validation data. For San Juan City, the values are pretty close as the graphs are almost overlapping. This way, we implemented multiple models to tackle our problem statement. Thank you.